Okay, last section for chapter 5. We are talking about half angle identities today. Okay, once again, you don't need to memorize them. Just get a little familiar with them so that you recognize them when you see them. So if we have sine of a over 2, that's equal to plus or minus root 1 minus cosine a all over 2. Cosine of a over 2, slightly different. We have a plus sign on the inside here. And then tangent of a over 2 is this one, which could be in any of these three forms. With the plus or minus, and I mentioned this in the last video, but we choose the sign, S-I-G-N, okay? So with the plus or minus, we choose the sign that is appropriate for the ratio of the angle based on the quadrant. Okay, so if our angle is in quadrant 2, sine is going to be positive, cosine is going to be negative, tangent is going to be negative, and then same thing for the reciprocals. Okay, so that's what we pay attention to. So we're not going to leave plus or minus in our answer unless it's one of the situations where we're just doing it in terms of like some letter A or something. Okay, in general, though, we're going to know which one it is based on which which quadrant the angle is in. Okay, so for these first few, we are simplifying. We are just recognizing which of the formulas is being used and rewriting it. So here I have a 1 plus cosine of something. So here that's my 1 plus cosine A all over 2 is equal to cosine of A over 2. If this is A, if A is 12x, then that means A over 2 is half of that, or 6x. So this is equal to cosine of 6x. Okay. Here I have sine of an angle over 1 plus cosine of that same angle. So that's this identity right here, which is equal to tangent of A over 2. So if A is equal to 47.6, then this is equal to tangent of half of 47.6, which would be 23.5 plus 0.3, so 23.8 degrees, okay, which I'm just going to leave, not evaluate. Okay, here I have, well, need a space in there, but here I've got 1 minus cosine of x over 5 over 1 plus cosine of x over 5. So that looks like this form right here, which is tangent of a over 2. A is x over 5. So tangent of half of that would be tangent of x over 10. Okay, can't evaluate that. It's in terms of x. And last one here, 1 minus cosine of 38 over 2, because it's 1 minus cosine. I'm looking at the sine identity. So that's going to be sine of, and then if A is 38 degrees, half of A is 19 degrees. Okay? All right, moving on. Use a half angle identity to find each exact value. Okay, so this, we're kind of going the other direction. So this is tangent of 22.5 that we are trying to find. All right, so this is my A over 2. If 22.5 is A over 2, then that means that A is twice that, which is 45 degrees. So this is, okay, now we need to pick one of our identities here. Let's use, here we go. We're going to use both of these and show that we end up with the same thing, but I'm not going to use that one. So sine A over 1 plus cosine A. So sine of A over, forgot my equal sign, over 1 plus cosine of A, again, 45 degrees. All right, so that's 1 over root 2 all over 1 plus 1 over root 2. Let's rationalize, so multiply by root 2 over root 2. We end up with 1 over root 2 plus 1. Okay, plug that into a calculator, I think it comes out to be like 0.41 something. Okay, and I'm only doing that to show that we get the same thing. Okay, so now that's the sine over 1 plus cosine. Let's also look at 1 minus cosine over sine and then try and decide which one might be better. Okay, so we could also do this as This is equal to cosine of 45 over 1 minus sine of 45. Did I write that down right? No, 1 minus cosine over sine. Back up. 1 minus cosine 45 over sine 45. All right, there we go. So then that becomes 1 minus 1 over root 2 all over 1 over root 2. Again, let's rationalize that. So multiply by root 2 on the top and bottom. I'm running into my other space, but that's okay. We end up with root 2 minus 1 over 1. Okay. If you plug this into the calculator, this also is 0.41 something. So yes, checks out. Both of those work. As far as deciding which one is better, it doesn't really matter. Me personally, I would choose this one. The reason I would choose this one is because this one only has a single term in my denominator as opposed to the 1 plus cosine. And I know that if I am doing this in Pearson, it's gonna want me to rationalize, and so then I don't have to rationalize with this root 2 plus 1, so I don't have to multiply by root 2 minus 1 over root 2 minus 1. Here I just had to get rid of the complex fractions. So this one, Pearson would have me do a little bit less computing or rewriting. So that's the one that I would pick because it only has one term in the denominator. Okay, so given the choice, go with that one. All right, next one, cosine of 15. Do that here. Okay, cosine of 15. So if a over 2 is 15, then that means a is 30. Okay, so cosine of a over 2 is equal to, plus or minus, we'll come back to that in a second, the square root of 1 plus cosine a, so cosine 30, all over 2. Okay. 15 degrees is in quadrant 1. Okay, so in quadrant 1, cosine is positive, so I do not need the plus or minus. I'm just keeping the positive. So this is going to be the square root of 1 plus, and then cosine of 30 is root 3 over 2. All of that is over 2, and I'm going to rationalize, or I'm going to get rid of that complex fraction by multiplying by 2 over 2 inside the radical, which gives me root 1, distribute the 2. 2 plus root 3 all over 4. You could stop there, but really, if we have the square root of a fraction, it's the square root of the top over the square root of the bottom. And in this case, I have a perfect square in my denominator, so I'm just going to make that a 2. So it's root 2 plus root 3 all over 2, not root 2. So that radical is only in the numerator. So this is my final answer. Sorry, kind of got squished with the other one there. Okay. All right, sine of 195. Okay, so sine of 195, if we write this as a over 2, if this is a over 2, then that means a is twice 195, which would be 390. Well, 390 is all the way around the circle plus another 30 degrees. So we're going to write this as the same as a being 30 degrees. Okay, because that is something we know how to evaluate. So sine of 195. Now 195 is originally in quadrant 3 because it's a little past 180. Quadrant 3. So is sine going to be positive or negative? Correct. Negative. I know you said negative. So we're going to do negative root 1 minus cosine of 30 all over 2. So negative root 1 minus root 3 over 2 all over 2. And I'm going to multiply by 2 over 2 again, just like I did over here. And I'll get negative root 2 minus root 3. And then that whole thing is over 2 because it's over a root 4, which is 2. Okay, next. Okay, so here we are looking for sine of x over 2, given that cosine is negative 5/8, and that x is between pi over 2 and pi, meaning that x is in quadrant 2. So sine of x over 2 is equal to, we're going to come back to that the SIGN sign in a second, is equal to plus or minus 1 minus cosine of x, or sorry, root 1 minus cosine of x all over 2, which, okay, now, I don't want to keep this plus or minus on here. Well, we can do the plus or minus at the end, but let's go ahead and think about it now. Since x is in quadrant 2, okay, that means x is this angle right here. X over 2 then has to be in quadrant 1. Another way to think about this is, let's say, we divide both of these by 2. Now we're saying, actually all three of these by 2. Now we're saying that x over 2 is between pi over 4 and pi over 2. So that means it has to be somewhere in here. Okay, so that means that sine of x over 2 is going to be in quadrant, or x over 2 is going to be in quadrant 1, meaning sine is positive. So we don't need this anymore. We are using the positive radical. Okay, so we get 1 minus, and then cosine of x is negative 5/8. So 1 minus negative 5/8 all over 2. I'm going to make that plus a positive, and I'm going to multiply by 8 over 8. Sorry, squish that in there, to get rid of my complex fraction. So we get root 8 plus 5 all over 16. So root 8 plus 5 is 13. Square root of 16 is 4. So root 13 over 4 is sine of x over 2. Okay, so here we are looking for tangent of theta over 2, given that cotangent of theta is equal to 4, and that theta is between 180 and 270 degrees. So that means that theta is in quadrant 3. If theta is in quadrant 3, actually, let's do it this way. We actually want to know what theta over 2, where theta over 2 could be. So if I divide everything by 2, I get 90 less than theta over 2 less than 135. So that tells me that theta is in quadrant 2, specifically somewhere inside here. Okay, so theta in quadrant 2, tangent is negative in quadrant 2, so tangent of theta over 2 will be negative. Okay, sorry, theta over 2 is in quadrant 2, not theta is in quadrant 2. Okay, so tangent of theta over 2, and now again I've got several identities to choose from. I'm going to pick the one that only has a single term in my denominator, which is 1 minus, stop that, 1 minus cosine theta over sine theta. Okay, now to figure out these ratios, I do want to go back to a triangle. So we'll come over here. Theta is in quadrant 3. Okay, so cotangent is equal to 4 over 1, meaning my adjacent is 4, my opposite is 1, and actually both of those are negative. So this is root 4 squared is 16 plus 1, so root 17 is my hypotenuse. All right, so this is 1 minus cosine of theta is equal to negative 4 over 17. Sorry, root 17. All over sine of theta is negative 1 over root 17. Getting rid of the complex fractions, I'm multiplying by root 17 over itself. So that gives me root 17, and then let's make this plus a positive. So plus 4 all over negative 1, which is negative root 17 minus 4. And that's our answer, which is negative. Okay. All right, last one here, sine of x, given that cosine of 2x is equal to 2/3. So something a little bit different here. Here, this is my a over 2 that I'm looking for, and this is a. Okay, so 2x is a, and x is a over 2. Okay, so using our half-angle identity, we get sine of x is equal to, and again, we'll choose the sign here, SIGN in a second. There's going to be 1 minus cosine of 2x all over 2. Okay, let's come back here. X is between pi and 3 pi over 2, which is in quadrant 3. So that means that, oh, actually, that's already x. So we're in quadrant 3. We don't need to divide anything by 2. and therefore sine is negative. So let's get rid of this. We have a negative there. Okay, so it's going to be negative root 1 minus, and then cosine of 2x is given as 2/3 over 2, and that is equal to negative, I'm going to multiply by 3 over 3 here. So negative root 3 minus 2 over 6, which is negative root 1/6, which is negative 1 over root 6. Okay, but you might be thinking, hey, wait a second. If this is a cosine of 2x, can't I just use a double angle identity? And you would be thinking correctly. If I'm solving for sine of x and I have cosine of 2x, I can use the identity that involves those two things, and I can say cosine of 2x is equal to 2 sine squared of x, and then I can solve for x. So let's see, cosine of 2x is equal to 2/3 equals 1 minus 2 sine squared x. Subtract 1 from both sides, I get negative 1/3 equals negative 2 sine squared of x. Divide both sides by negative 2. Oops, divide by negative 2, that becomes positive. Come over here. So I get 1/6 equals sine squared of x. Then I take the square root of both sides, and I do need a plus or minus here. Plus or minus root 1 over 6 is equal to sine x. However, when I go back and remember that sine needs to be negative because x is in quadrant 3, then we know we're keeping the negative between the two of these. So sine x is equal to negative 1 over root 6, which is the same thing we got with the half angle identity. Okay, so if you recognize that a different identity will work, any previous identity is still fair game. Just because we're in section 5.6 doesn't mean we can't use something that we learned previously.